Mathematics, Analysis and Approaches, Paper 1, Timezone 1, HL, November 2025, question number 5. The question talks about an expansion of 1 minus x to the power of minus 4. He tells the Maclaurin series expansion of that is so and so, and then you have to find a value for a and b. Using that, he is also asking you to find the depreciated, the initial cost when the cost of the a car was depreciated to $1,000. We will use the concept of multipliers over here. I'll explain that to you. Before we could go there, let's understand the Maclaurin series, and also let's see how we can use a binomial theorem into this one. Okay, so Maclaurin series helps us in identifying a function which can be expressed as parts of an infinite terms. Okay, so any function, let's say cos x or even sin x or e to the power of x, can be written like that, which is f of 0 plus x divided by 1 factorial into f dash of 0 plus x squared divided by 2 factorial into f double dash of 0 plus x cubed divided by 3 factorial into f triple dash of 0. And this continues. This is your Maclaurin expansion. Binomial theorem can be applied for polynomial, which can be expressed as a power of something. Because this is a polynomial, I can apply both Maclaurin and binomial. Understand that Maclaurin can go till infinite terms. However, binomial ends at term 4 in this case. So what is my binomial expansion? And here when I talk about binomial expansion, I'm talking about a rational power, right? So I'm going to write the expansion of 1 plus x to the power of n, and understand here n is a rational number. It's going to be a 1 plus nc1. nc1 is basically a n into x to the power of 1. And then we would have a nc2. nc2 is nothing but n into n minus 1 divided by 2 factorial into x squared plus n into n minus 1 into n minus 2 divided by 3 factorial into x cubed plus n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial into x to the power of 4. And yeah, that's the expansion, and this continues till the nth term, or the n plus 1th term in the binomial expansion. So if I'm applying binomial expansion for, let's say, 1 minus x to the power of minus 4, what would it be? I would write a 1 plus minus 4 times of x. In this case, x is negative, so I'm going to write a minus x plus minus 4 into minus 5, which is n minus 1 divided by 2 factorial into minus x to the power of 2 plus minus 4 into minus 5 into minus 6 divided by 3 factorial into minus x to the power of 3. And this continues. I think I can stop it here because he's only looking for x cubed, so I can stop it there. So what is this going to be equal to? This is going to be 1 plus 4x, and 4 5 is 20. 20 divided by 2 is a 10, and this is going to be a positive, so plus 10x. So now you can see here, this is 4 5 is 20, which is positive. However, there's a negative over here, so 6 factorial, 6 is nothing but 3 factorial, but the negative will remain, and hence is going to be a positive 20 x cubed. Negative, negative into negative, and another negative, so overall it becomes a positive term. So that is it. If I look at this one, I directly can say that the value for a is a 4 and the value for b is 10. So how does the Maclaurin series help us over here? For that, I'm going to take f of x, which is 1 minus x. That's my function, raised to the power of minus 4. And here, I'm going to first find out f of 0. F of 0 is 1 raised to minus 4, which is simply a 1. And I'm now going to differentiate the function. Differentiation of this is minus 4 into 1 minus x to the power of minus 5. And then I'm going to find f dash of 0. F dash of 0, you can see, is this is going to have a negative 1, is going to be a 4, and then f double dash of x is simply going to be minus 4 into minus 5 into 1 minus x to the power of minus 6 into again a negative 1 and then a negative 1 because of the function being negative. So f double dash of 0 is simply going to be 1, 2, 3, 4. So that's 4, 5 is 20. And now f triple dash of x. So let's differentiate this. Minus 4 into minus 5, that remains. Now when I'm differentiating the function, it's minus 6 into 1 minus x to the power of minus 7. That will have a negative. These two are going to become positive. So overall I'll have a negative. And from here I can say that f triple dash of 0 is simply going to be a positive, which is 5 4s are 20, 120, and that's it. So let's go to Maclaurin expansion. Maclaurin expansion simply says is equal to f of 0 plus x times of f dash of 0 plus x squared divided by 2 factorial into f double dash of 0 plus x cubed divided by 3 factorial into f triple dash of 0. So f of 0, I've already calculated that, which is a 1, plus x into f dash of 0 will be a 4 plus x squared divided by 2 factorial into f double dash of 0, which is a 20, plus x cubed by 3 factorial into 120. So if I can rewrite this, this is simply going to be 1 plus 4x plus 10x squared plus, this is going to be a 120 divided by 6 is nothing but 20. Okay, so both the methods are fine. Whatever you feel comfortable with, please go ahead with that. Okay, at times binomial seems easy, but remember this is only possible if the function itself is a polynomial. Otherwise we can't really use both methods. Okay, so that's the solution for the part A. Now let's look at part B. What is he saying here? The car was purchased 4 years ago. The car depreciated in value by 10% each year. And the value of the car is today 1,000. Was some V. Okay, some V. Every year the value of the car has been depreciating by 10%. So the value of the car in the next year will be V minus 10% of V. V minus 10% of V, which means I can take V common out and I'll have a 10 divided by 100, which is nothing but 1 minus 0.1, and what I get is a 0.9, and this 0.9 is known as a multiplier. When something is reducing by a particular percentage, we do a 1 minus of that percentage. In this case 10%. If it was decreasing by 20%, then the multiplier would become 0.8. Other way around, when the something is increasing by 20% every year, then your multiplier would become 1.2. Okay, great. So the value, whatever the initial value was, now that got depreciated every year by 0.9 for how many years? 4 years. And that resulted in the present value, which is 1,000. This is the situation. So the initial value can now be written as 1,000 divided by 0.9 to the power of 4, which means the initial value is 1,000 multiplied with 0.9 to the power of minus 4. I hope you see why we have to use part A here. This now is 1,000 into 1 minus 0.1 raised to the power of minus 4. And we already know this expansion. Yeah, we know that expansion. What is that expansion? That expansion is this. 1 plus 4x plus 10x squared plus 20x cubed. So 1 minus x to the power of minus 4 is 1 plus 4x plus 10x squared plus 20x cubed. Let me cross check that. 1 plus 4x plus 10x squared plus 20x cubed. Now I know that the value for x is going to be a 0.1. Therefore the initial value is 1,000 multiplied with 1 plus 4 into 0.1 plus 10 into 0.1 square plus 20 into 0.1 cube. Let's quickly expand this. This is 1000, 1 plus, I'm going to write this as 4 by 10 plus 10 divided by 100 plus 20 divided by 1000. 0.1 is 1 over 10. Okay, I hope you know that's what I'm doing. So what is this going to be? 1000 multiplied with 1 plus 4 divided by 10 plus 1 divided by 10 plus 20 divided by 100, and that is simply 1000 into 1 plus 0.4 plus 0.1 plus this is not going to be 20. This is going to be a 2 divided by 100. This is 0.02. So that's 1, 0.4, 0.1, 0.02, which is 1.52. And therefore I remain with 1000 multiplied with 1.52, which is 1520. Therefore now I can conclude that the initial value of the car was $1,520. Okay, all right, that's it. I mean, we can look at the mark scheme here. For section B or part B, we had 2 marks, which is basically to get this value, which is the final value of the car, which is 1,520, which is A1, and substituting the value of 0.1, which is basically making use of the previous proof, and substituting the value for x is equal to 0.1. There you get a method 1 mark, so that's your 2 marks. Okay, now section A has 5 marks, and that's a bit lengthy. So for that, getting the value for B, that gives you 1 mark, and obviously getting the value for A gets you 1 mark. So depending on the method you have applied, either be it the binomial expansion way, or either be it the Maclaurin series expansion way, your 3 marks are avoided for the different steps. If I start discussing all of them, the video will just go lengthy. Just understand that both the methods are fine, and these are going to be your marks. That's it for the video. Thank you.